So today we have a grid with this kind of big numbers n and m, 10 to the power of 9, and we also given these red bars that we can remove. And we ask to find in this grid, if we remove the red bars, what is the maximum square area. So if we remove this red bar, we have like this squared area, and this area is not squared, however it also is removed. Now there are some different ways to solve it, and after you understood this problem, you just have to consider this as separate problems for the horizontal and for the vertical bars. And after you find the consequent intervals of horizontal bars or vertical bars, you just know that there are some lengths that are merged for the horizontal and same for the vertical bars. And that means after we find this merged intervals, we can find the maximum, and then we can just do union between horizontal and vertical, and they can be different at lengths, but we should take the minimum because we care about square. Now the sub-problem is finding merged intervals. How can we do this? And this problem is kind of not very hard. We have 10 to the power of 9 numbers, but only 100 of them. And one way is to sort. It would be like this: 1, 2, 3, 7, 8, 9, and this is consequent intervals, and we care about them. And these gaps is what we not care about. Now just iterate over sorted values, use some counter, and pick the maximum. And if you find the gap, you should reset the counter. This is one way to solve it. However, this solution is of n log n because you have to sort. However, there is a of n solution, and it is because we have the rule that the previous value should be exactly next value. So 1 plus previous is the next. And that means if we can avoid sorting by using HashMap with the values. And this HashMap would keep this original coordinate and the width of the interval. So if we have some numbers, let's look at this number, we look at this position and at this position and ask what the visited known intervals and if we have, we just merge them. So it would be m like x minus left equal new width, and new width is 1 plus left plus right, and same for the right, x plus right. So this is kind of an solution for merging intervals. Now let's look at the code. The accepted solution, I kind of spent 70 minutes because I have trouble to do this off by one errors. You have to load the entire picture in your mind to operate with this initial values. I stopped at this like 2, but essentially you have to just do +1 here instead, and you can just pick this as 1. Now let's look at the golfed solution. I like to compress the code. Here's my Rust solution. We can iterate over H and V in the same way. So we put in this in the list and then map, then we sort, and then in Rust we have the function that chunks by some k, and the k is difference between numbers. So if the difference is 1, it's an interesting chunk. Then we just take this length of the chunks, do +1, and then find the minimum of these two. This is a maximum of chunks, and this is a minimum of horizontal and vertical. Then we do a squaring operation, and this is solution. Now let's look at the Kotlin golf with hash maps. This is a hash map for the intervals. We are looking for the left of -1 and for the right of +1. And this is the interval lengths of left plus right +1. And also we write updating the left, but this is not -1, this is -L. So it's kind of interesting. And I also skipped the writing to mx, and it is accepted. So that means it's not necessary to write at exact position. So this is how it works, and the code is a little bit faster than with sorting. Like if we have this form of using separate function and without golfing, the solution is only 5 milliseconds. And it also writes into the middle, but this is not necessary. So I think that's it for today.